Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello.
Russ. Hello.
James.
Yeah, how are you doing?
I'm doing well.
We were talking last night in the little speakers event that we haven't actually seen each other since before COVID, I guess.
Yeah, maybe 2018, something.
Yeah. And we seem to be sort of conference buddies. I think you had a memory of me leading you around London late at night after QCon or something like that, which is probably...
So I don't really remember QCon, but I do remember the alcohol that followed QCon to a certain degree. So
that's not something that I would recommend, obviously. So I think the first thing we're going to talk about, if that's all right with you, is functional programming and your love of functional programming, really. So I wonder, maybe you could talk about how you sort of started with functional programming.
Sure.
And yeah, we'll go from that.
Okay. Well, I think my experience with functional programming is similar to a lot of people's experience, where you start reading or seeing very smart people talking about this is a better way of doing it. And, lots of reasoned arguments about why it is a better way, that you can reason about the code a little bit better, it's easier to test and all that kind of stuff. And then my experience was running into an absolute brick wall of trying to figure out how could I possibly write practical programs with, functional programming is essentially a set of more or less arbitrary rules for how to write programs. And it's exactly, I was thinking about this coming into the conference today, it's exactly like back in the 60s or 70s or whatever, somebody saying, no, don't use GOTOs in your program anymore. And the reaction to that, which was, how the heck do I write programs without GOTOs? And of course, and slowly kind of unraveling the secret of how you do functional programming and discovering that much of what people write and say about functional programming is well-meaning and correct and not helpful at all. And it's not helpful. So it's not helpful because it gets tangled up in terminology. It's not helpful because it's kind of describing the end result of a long thought process. And what's more helpful, what managed to help me sort of break through, is to start at the beginning and go through the thought process that leads to functional programming. Things like, these are an arbitrary set of rules that we're imposing on our program because we think it will make the code easier to understand, easier to reason about. Okay, if that's the starting point, then okay, I will follow you along to the point where maybe I will understand functional programming. Maybe not, but maybe. And that's certainly more helpful than saying, we have these things called monads, right? And that kind of thing.
What do you mean you don't understand category theory? Come on,
yeah,
get out.
Right, yes, exactly. Yeah. And I also think one of the problems, just kind of a silly thing with functional programming, is since it comes out, many of the ideas come out of like the world's math, right? It's functions as in the functions you learned in school about mathematics, is so many of the examples that people give and the easy examples to give are all about numbers. And while practical programs, yes, deal in numbers, we're much more likely to deal in text and structures and big conglomerates. It's all equally true. But it's just, if all you're talking about numbers, it's sort of hard to map that.
Every sufficiently complicated piece of enterprise software starts with doing the Fibonacci sequence.
Yeah.
Right? It's a bit like the spherical racehorse in a vacuum from physics. It's spherical chicken in a vacuum.
But that's one of the so my background is that I've been an engineer and then a manager of engineers and then an engineer again and back and forth. And so I spent a lot of my career teaching people, new things, new ways to program and that sort of thing. And just the choice of examples when you're trying to teach somebody like how to program in a different way makes a huge difference. And the reason I know that sort of in my core is that, and this is going to sound shocking to a room full of programmers, I hate games in most forms, most of the time. And so many programming examples are, let's do this game. Who plays the Tower of Hanoi? Has anybody ever actually done that, right? And, and I think examples should be like when you're trying to teach somebody something, an example should start with something that the person knows already, So, like, if I get up every morning and make breakfast, then start with the how to make breakfast example. Don't start me with how to run a 5-star restaurant, because not a lot of us know how to do that.
I was reading because you have a new book. Is it just out, or is it?
I'm still working on it.
Still working on it. It's early access, maybe. Is it?
No, I'm still. So it was going to be. I was going to have early access for this conference, but you know how authors are, right?
What was the Douglas Adams quote? Do you know that about deadlines? I love deadlines. I love the sound they make as they swoosh by. It's a wonderful line.
Well, there's a publishing thing which is like a year late is 6 months early or something.
So back to the book, because I did want to talk about it because it sounds absolutely fascinating, and I think it talks specifically to what you've been explaining there. Hey, see what I did? Which is called Getting Clojure, right? And it's
so that's the book that's out.
That's out,
yeah.
Right.
So, and you should all buy many copies. So Getting Clojure is a book about it's about the Clojure programming language, but it's really about how do I figure out functional programming given that I'm learning Clojure, because Clojure is such a functional language that if you really can program in Clojure, you are a functional program. You get it. It's not like, Scala or something, nothing wrong with Scala, but you could be a Scala program and ignore the functional aspects of Clojure or of Scala. If you're a Clojure programmer and you ignore the functional aspects of Clojure, I think you could print Hello World and you'd be done. So Getting Clojure has been out for a while, and it's a book. So Clojure is a Lisp programming language, and it's a book that's trying to explain a Lisp programming language. And I wrote it a few years ago, and I started thinking about how so Lisp is another one of those things like functional programming, which people find hard. I found difficult to really get my arms around. Again, it was something that smart people that I respected. I remember one of my early mentors said that there were more ideas per byte in Lisp than any other piece of software ever, right? And so, how can you turn that down? And again, it was like completely impenetrable. How I eventually figured out Lisp was I wrote my own, right? Which is not terribly difficult. It was a lot more difficult because I did it in Fortran. It was the language we had. But once I had built it myself, I understood everything about it. It was like that was the easiest path to Lisp. And so the book I'm working on right now is called The Lisp Adventure. Right. And that is a book about implementing Lisp. Like, you want to learn Lisp? Let's build one together. And we'll build it in Python, because everybody sort of half knows Python now. Build a Lisp in Python. I guarantee you, if you go through this exercise, in the end, you will understand Lisp. This all sort of reflects what I feel really strongly, which is there is not one way to teach things. There is not one way to understand things. But we have this go-to thing, which is if I want to explain something to you, I want you to understand something, I do this like top-down explanation. Here are the big ideas, and here are the more refined ideas, and here's how we practically put them together. That works some of the time. That's fine, but it's not not the only tool you have. You know, if you're trying to understand, if you're trying to teach some software, maybe a good way to do that is to have the person implement a toy version of it or something else. You know, it's like, I think explaining technical concepts is one of the few places where engineers tend to do a thing, see it fail, do it exactly the same way a second time, see it fail, and just repeat until, you know, there's no one left in the room. I don't know. So
I think there's the opposite of that as well, because if you do something once and it works, then you do that everywhere.
There is that, yes.
And you don't learn stuff as well. There's the kind of second system syndrome thing as well, like as opposed to the fail system syndrome, I think.
Yeah. Well, I think second system syndrome is also a good one, because I've seen people, another common explanation failure mode is, I explained the basics to you and it worked. So the next person who comes along, I'm going to explain it in excruciating detail, and they're going to lose the big picture for all the details. That is a really common failure mode in explanations.
So going back to Clojure, so I want to caveat this with, I've never written production Clojure code. Sorry everyone. However, I did go on a course with Stu Halloway.
Oh, sure.
Some years ago in London, we brought Stu over to do a course for us. It was remarkable for a number of reasons. One of which, I was smoking at the time. I'd go and have a cigarette, and Stu would do 20, 30, 40, 50 press-ups. I thought that was like, if there's a difference between someone in the US and the UK, that's one of those differences. But it blew my mind, and I ended up getting a lot more into the concepts in functional programming. I read structured interpretation, computer programming. I went down that sort of route. And we've had lots of Clojure projects in Thoughtworks over the years. One of the things that keeps coming back, and I noticed it when I was solving toy problems in Clojure, was that I found, like, the terseness, the elegance of it was amazing when I was writing it, and I had to think about it a lot before writing. But I found it often, when I went back to it, harder for me to understand than some other languages I've written software in.
I think there's some of that. I think of Clojure as, we took a tour of a distillery last night. Yeah. And I was thinking about that in terms of Clojure. Somehow Clojure is like 80-proof programming language. It's you can get a lot of. So in my talk on Thursday, I think, I'm going to talk a little bit about Pedestal, which is this Clojure library. And it's hard for me to talk about Pedestal because, one of my slides says Pedestal. It's 10,000 lines of Clojure. And in many programming languages, you'd be thinking, 10,000 lines. But it's like, I want to jump up and down on the stage and say, no, this is 10,000 lines of Clojure, right? This is like all the Clojure that's ever been written. There is certainly some of that, but it's a very terse language. One of the things I think, so one of the other things that I find wonderful about programming and software engineering is it's as much cultural as it is technical, And one of the things that Clojure programmers do to fight the write-only aspect of the code, where you can write it but you can't read it again, is they adopt certain patterns so that you can look at the code and you can say, yes, this is a chain of functions because I always write them the same way, and therefore I can make sense of it, And so you can chunk up the code in your mind, except that culturally, and, I'm probably going to have people with torches and pitchforks at my door tomorrow for saying this, the word pattern in the Clojure community, you cannot say that word. Right, because it's the sort of holdover from people abusing design patterns and stuff like that. So in the Clojure world, we're against patterns. We will tell you this is how we do it in Clojure, but that is not a pattern, right? And it's just this wonderful sort of cultural quirk, use a different word and you're fine. So
at this point, has anyone in the room got any questions? Functional programming, Clojure.
Stay with us. We'll be right back. Now in its 5th season, Inspiring Tech Leaders is the podcast that talks about technology strategies, challenges and breakthroughs shaping today's digital world. Each week, Inspiring Tech Leaders brings you technology reviews and interviews with visionary CIOs, CTOs and industry pioneers. Whether you're leading a tech team or just love innovation, Inspiring Tech Leaders is your go-to source for inspiration and real-world advice. Subscribe now on your favourite podcast platform.
Hi, so I'm a big fan of functional programming too. And one thing, even though I can see the benefits and I get really excited about it, I found it a little difficult to bring other people along with me on that journey, right? So when they used to sort of Java or Go, imperative or object-oriented style of programming, it can be hard to sell them on, why functional programming could be a good choice. Any advice for how you could sort of bring people along?
Yes. Come to my talk on Thursday. But so I think there's the functional programming specific aspect answer to your question, and then there's the general sort of helping people see a different way, just that would apply to anything. And the helping people see it a different way is, for the love of God, do not say, this will change everything, this will change your life, because nobody ever believes that. What you want to say is, this is a slightly better way. This will make your life incrementally better. Okay? Make your programming life incrementally better. The rest of it is your problem. On the functional side of it, there are straightforward arguments that just go like this. Hey, that math library? We never worry about if cosine is correct. We never worry that absolute value, that function, is correct. We just know they are. And one of the reasons we know they're correct is that they are pure functions. They are easy to test. We know what will go in and what will come out. Wouldn't it be wonderful if when we process the employee record or whatever, that it has the same characteristics? Because that fundamentally is the fundamental proposition of functional programming, is that if we can make everything behave the way the absolute value function or the cosine function is, our lives get easier. And so it's very, get away from the arm waving and the ethereal, this is a pure function and therefore it lives in heaven or whatever, and get it down to something very gritty and very practical. And that's how you change people's minds.
So what you've spoken about there is quite, it's zoomed in, right? You're talking about individual functions and things like that. But if I was going to sell a team on it, I would want to say, I don't know, if you can use this, it will reduce the number of bugs you have per, the rate at which you have bugs, or it makes it easier to maintain or something like that. And I struggle to find here's some evidence that this is actually true, right? If that makes sense.
I think you have to sort of change minds a little bit before you can change them in a big way. So you have to sort of prepare the road. But you can also sort of make arguments which part of the system is harder to test? The part that updates the database or the part that does something, more, every practical system has some pieces of it that tend to be more functional, right? And functional programming in the main is more about moving everything away from, minimizing the amount of side effects and interactions with the messy environment, and building this core of stuff that's relatively easy to test and relatively easy to reason about. And so, it's easier to make the argument that we're just migrating some of the stuff. Again, one of the difficulties with functional programming is people see it as this binary choice, and it's really not, So I hope that answers your question. Sir?
First, I want to apologise for seemingly name dropping. I have a podcast, and I was talking to Michael Feathers, and we were discussing functional programming and object-oriented programming. And he said something that resonated with me as an old-school object-oriented programmer, is that good object-oriented programming looks quite a lot like functional programming. It has minimal side effects, and it has, all of these kinds of things. We try and design to isolate those sorts of things. I just wondered what you thought about that as an idea, because it seems to me that we seem to try and build this wall, this divide between declarative and object-oriented programming and functional programming very often.
So now, I have these two hats, right? I'm a fan of functional programming hat, and then I have a Clojure hat, which is very much overlapping. The Clojure idea is that data should be stupid, right? Data is just data. And then you have a bunch of functions that operate on the data, right? What is it? Better to have 1,000 functions operating on 3 pieces of data than 1,000 bits of data with 3 methods each, right? So I think that, object-oriented code is about organizing your data, organizing your programs around the data. And very much the Clojure flavor of functional programming is, no, that's just conceptually awkward. It's not horrible, it's not horrendous, it's just conceptually awkward. And it's better to just say, the data is there, it's dumb, it's just there. And then we have very smart functions that operate on the data. So, sure, you can take your object-oriented code and drive it in a functional way. And if I were you, I'd be all over that. If that's the way to get from here to there, yes, do that. If I'm starting, from a clean sheet of paper, I might do something else. So,
just as a side note to that, if you don't mind, that's been my experience with, say, Java or C# over the years. Is especially if you test drive your code, you tend to end up with these very small units of code, very small objects, which have probably small numbers of functions in them, which are tested and blah, blah, blah. So, that resonates strongly with me anyway,
The immutability of the data is really the key thing, right? And then, you and I can sit down over a beer and argue about how it should be grouped together. But once you get to the point where you're saying, I shouldn't be mutating this data because that makes life hard, we're in essential agreement. I'll buy you a beer.
Let me jump on that. I come from a world with everybody's favorite programming language, Java. And I'm used to just writing or preferring immutable data structures and functions without side effects, which are effectively functional. And when you can do this already there, you get all the benefits. And it also helps with people, of course. But I'm wondering, I also did a bit of Clojure. And I right now cannot imagine using Clojure in a production environment because of the write-only aspect, which I also noticed. But also because if I can do it this way, and you have a lot of people who have a big skill set in Java overall, it's easier to teach them to write functional code in Java.
Sure.
And it's really hard to write production code in Clojure, I find. So is it a good idea to actually write production code in Clojure besides specific use cases?
So my most recent job was with a bank. So possibly the most boring application ever, to be honest, right? We're just moving money around, right? This bank, when I started, was a Clojure monoculture. Every line of production code was more or less written in Clojure, okay? This bank has 100 million customers. So there's an existence proof that yes, you can write.
More about not if you can probably, but does it make sense?
So
most applications are usually have a user interface and everything, and a lot of side effects that you have to do, like whatever, databases and so on.
Right. So great question, because you're getting at, I think, one of the misconceptions about functional programming, which is really widespread. So I will say this. In the bank, the user interface is not written in Clojure. Right. So fair enough, but the backends entirely are. But functional programming is not about getting rid of side effects. It is about getting rid of using side effects as a tool, okay? Because, ladies and gentlemen, we are all in the side effect business, right? Everything our customers care about, update the database, write the file, generate the report, do the user interface, they're all side effects, right? So if someone comes to you and says functional programming is all about getting rid of side effects, well, guess what? You've now built a program that maybe we would like, but our customers will hate because it won't do anything. So functional programming is really about building the core of your program so that it does not use side effects as a tool to get things done. And then sort of on the outside, perpetrate those side effects to get the final result you're looking for, write the report, update the database, or whatever. So I think your other point is this would be a hard transition to make, right? I've got people, they know how to do Java, and yes, that is a thing. But I was thinking about with this gentleman's question about sort of doing functional programming in Java, I've been around long enough, like I predate the object-oriented world, right? When I started, object-oriented programming was in an earlier stage of development than I think functional programming is today. And we had lots and lots of discussions about using these object things, and nobody knows how the heck to do them, and we're going to have to retrain people. And there were lots of people, including me, who were writing object-oriented code in C, right? You did it by hand, and I think the parallel is there. So yeah, is it a difficult transition? Sure. Is it worth doing? I think that's up to you and your company and whatever. But these transitions, it's like how we, if I'm right, functional programming is sort of a transition you should make. Maybe I'm wrong, but there will be another one. It's how we make progress in the industry. We do different things. If you just think about your application and designing systems, a new paradigm, right? Like if I have to deal with a new paradigm, like maybe I'm going to put a message bus in my system or something like that. That's a day that ends in Y for engineers, right? That's like every day of the week we do that. This is just a larger scale one of those.
I don't know if you can comment on this, but it also, for me, it's about diversity of thought as well, and diversity of technique. To have your mind open to, even if you're not using it every day-to-day basis, it made me a better programmer. Understanding. Yeah,
I think there's something to, and it's great to hear people sort of talking about, I'm thinking about doing this, you tried out Clojure. I think, forget the industry and moving forward. How do you move forward in your own career, right? If you're not trying things out and, playing with stupid ideas, well, you should be. So.
You heard it here first, folks. We're going to change it up a bit now, I think, because obviously, Russ, you're speaking twice at GOTO this time. And the second talk you're doing, the keynote, is called To the Moon. Yes. So obviously, without talking about what you're going to talk about, as it were, can you just explain to me, explain a bit about why that topic's so important to you?
So I've done this talk before, and the first time I did this talk, a friend of mine went to the talk, and then after it was over, he said, I feel like I have heard this entire talk only 10 minutes at a time over lunch, right? And it's basically, talking about what I'm going to talk about, it's about the Apollo moon landings and the effect that it had on people. Forget about gathering up some moon rocks. That was great. Forget about the technology. It had this enormous effect on the people who were around. And I think we have all, if you're doing this, you probably have all experienced a moon landing. And by that, I mean, you've all experienced a person, a product, a book, or something where you just wanted to stand up and say, yes, this is what I want to do, right? Why are you all here, right? Smart people could do a lot of things. And for many of us, it was the moon landing. And so, but I think the difference between the people who experienced the moon landing and those of us who came after it is there isn't a single pivotal moment, maybe for most of you. So you don't have the chance to come to a venue like this and say, oh yeah, let's talk about this common experience, because yours was a book, yours was some professor, yours was some product or some piece of technology that really inspired you. So it's all different, but we've all had this inspiration, but we tend not to talk about it, you know? And so a big part of that talk is, hey, let's talk about this an inspiring moment. So
yeah, it really was for me when I saw it. What I find interesting about the story of Apollo, because it's not just about Apollo, it's about all the precursors to Apollo. It's about hundreds of thousands of people coming together with a shared purpose, and there are a number of other instances of that throughout history, and I think we don't talk about them enough somehow. I'm thinking. I know they're slightly dodgy topics, not dodgy, but I mean, they're not great topics to discuss from a political or societal perspective. But Los Alamos, the Manhattan Project, is another example of this incredible group of people getting together for a single purpose. You could argue also during the pandemic, the race for the vaccine, was another one of these things.
Yes, more vaccines, fewer atomic bombs. That would be my vote. As I say, I think there are galvanizing moments, and for good and for ill. And one of the advantages that people who have shared galvanizing moments have is that they get to talk about them because, you know, hey, how about when you got your vaccine, right? We could talk about that. But if our galvanizing moments are different, then we tend not to talk about it. And, you know, engineers were like the right now, what's the problem of today or tomorrow? We just are not wired to talk about these things anyway. So that's what they pay me for.
Another thing that I've observed about these things, and after listening to you talk about Apollo as well, is how actually there's similarities in approaches to how you solve these giant problems. For example, with vaccine development, it was about concurrent set-based engineering. Essentially, they did all the same things, except they did them at the same time, except in a pipeline. It's an interesting thing that when we really need to do something, we fall back on these patterns, I think.
I think one of the interesting things about Apollo, and this is giving away, here's a spoiler from the talk. One of the interesting things about Apollo is they took the most insane engineering approach and made it work, which is, you know, I need to build this new, effectively a technology chain, right? I need to do A, and B depends on A, and C depends on B, all the way along. Hey, we don't really have a lot of time, so we're going to build them all at the same time, right? So we're going to build A, we're going to build B, and we are going to pray that they all come together and work together at the last minute, because as we all know, that's a great engineering strategy. But they made it work, so yeah.
Does anyone have any questions at this point?
How did they make it work?
I think the answer is persistence. They pulled it all together, but they're also, and this is not something I recommend for vaccines or various other things, they were willing to take incredible risks. So the vehicle that they had actually landed on the moon with had flown twice before they landed on the moon. So think about an airplane. This is the third time we're building the 747 and it's a brand new airplane. We're going to fly it twice and then we're going to put your butt in it and fly it across the Atlantic Ocean, right? You probably would not sign up for that. And in fact, even after the first moon landing, they were so wired for risk tolerance that they did crazy things that in retrospect were just insane. So for instance, the second moon landing mission, they launched it in a thunderstorm because nobody could think of a reason why not launch it during a thunderstorm. And it turned out that the reason that you don't launch a rocket in a thunderstorm is that, you know, the big trail of flame that comes out of the bottom of the rocket, it conducts electricity. So they generated this mile-high lightning rod, and the spaceship got hit by lightning twice on the way up, and every computer, every system in the spaceship went down except just by chance the one that was steering the big rocket. And so they survived that. I mean, it's just insane. Like, it's a thunderstorm and we can't think of a reason not to go.
Do you know Dr. Anita Singh Gupta? If you've come across her on your travels, she's one of the principal investigators for Curiosity.
Oh, right. Yeah.
She was the principal investigator for the landing component of the Curiosity Mars rover. Yeah, she designed the parachute system. Yeah, it's this crazy thing. I don't know if you've come across this, but it's a crazy system where you decelerate, come into orbit, and then parachutes deploy, and it floats down, and then it deploys the rover on cables, and as hovering, and then it flies off, leaving the rover there. And we were at this. It was actually a GOTO event in Chicago. She did the evening keynote, and one of the audience asked a question, so what do you do about redundancy? What happens if components go wrong? And she literally just fell about laughing. Right? She said, what do you mean redundancy? This is space. You can't carry redundancy. Redundancy is weight. Weight is money, it's fuel, etc. She said, we like to use this little thing we call engineering tolerance. And all the software people in the room went, oh. It was a wonderful moment.
That is one of my pet peeves with software engineers. So let me say this all to you. So I am a former mechanical engineer. I'm a reformed mechanical engineer. And one of the things that drives me absolutely crazy that software engineers will occasionally say is something like, oh my goodness, the software engineering, writing programs, building systems, it's so hard, and we don't really understand how to do it. It's not easy like building a car, right? And it's like, excuse me? or, my wife was interested in civil engineering. It's not easy like building a bridge, right? Try and build a bridge.
Cool. Do we have any more questions?
I confess it's a little bit of a loaded question, but how does that sort of engineering no sort of fault tolerance, how does that really play in with like Agile and TDD? That is a failure-based process, I would argue, right?
So I think Agile and TDD are the beginning of a road that leads you to things like chaos engineering, right? And here the idea is not that nothing ever fails. The idea is things fail and we don't care, And so the resiliency in your system is not to build a perfect system. It is to build a system that doesn't fail sort of from the outside in a significant way. So in mechanical engineering terms, I would think of it as ideally we would build a system where nothing ever wears. But real engines, real brakes, they wear, but you just don't want them to like wear out and fail catastrophically. And that's what we're trying to get to with computer systems. You'll buy that, right?
So we are lucky actually to have Russ here because he had to climb up some stairs and he's not very good at heights apparently. But so that's awesome.
So since I do talk about the moon landing quite a bit, people will sometimes ask me if I want to be an astronaut. And I will quote something from, we were talking about the TV show The West Wing, and this is a line from The West Wing, which is, I would make a great astronaut, except that I'm afraid of heights, enclosed spaces, and fire.
Fantastic. Okay, well, I think that's probably the top of the hour. Thank you very much, Russ, for joining us.
Thanks, everyone.
Thank you.
Thank you.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.